Welcome to Physics Solution, and today we are going to do another physics problem related to dimension analysis. Alright, so today we are going to do this problem. Suppose that the displacement of an object is related to time according to the expression x equal to bt squared. So the expression that we are interested is x is equal to bt squared. What is the dimension of b? So here you have two different dimensions. So suppose the displacement, so x is your displacement, which is basically your length, has a dimension of length. So and t square nonetheless is the dimension is time, so it has a dimension of time squared. So what is the connection between these two? Remember, you have to follow the rules. A, dimension analysis should be consistent, and B, constants don't have numbers. Okay, when I say constant, I mean actually numbers. So numbers don't have dimensions. Okay, so here the consistency is kind of missing, but don't worry, B is still there. So we have to find a way to make this B consistent with the dimension. So what we can do is we have to find the dimension of B. So x is L, so we'll write that down here, and then B, we have no idea what B is, and t square, so that has a dimension of t the whole square. So B, by simple mathematics, you will know that B is nothing but L divided by t. You can bring that down here and you get t squared. So you can bring so you can nicely tie up the end to the square. So this would be the dimension of your expression B. Let's check whether this is true. So you have x equal to b t squared. X has the length, a dimension of length, and b has a dimension of L. T minus 2 times t squared. So t to the whole power. These two will become t to the power negative 2 plus positive 2. They go to 0 and you're left with L equal to L. So voilà. So the consistency is maintained. Therefore, your dimension analysis is correct. Now, so moving on to the second part. So we have a dimension. So the second part is dimensions related to time as x equal to a sine 2t ft, where a and f are constants. Find the dimensions of a. Hint: trigonometric functions appearing in an equation must be dimensionless. Okay, so how do we proceed with this one? So you might have known, okay, so the equation, let's just write that down here. So the equation that we are interested in is x equal to a sine 2ft. So x equal to a sine 2 pi ft. Now t, you will understand that it has a dimension of time, but you have f. F is a frequency, so f are constant. Okay, so to f, let's that. Okay, but you when you put that on a trigonometric scale, you're converting this entire formula right here into a constant, into a number. So therefore the dimension is observed in a trigonometric function. Therefore this whole deal right here has no dimension. So this part is dimensionless, which is which is also hinted in the question. So a trigonometric function appearing in an equation must be dimensionless. So there you have the hint. So therefore you can proceed with just A. So if x is basically the displacement, so therefore it has the dimension of length. So therefore you have the dimension over here is 0, or it has no dimension. So therefore A by simply equating, you can see that A should be of dimension length, which is true because A is the amplitude, A is the maximum displacement of the of this of a particle which is undergoing a simple harmonic motion. So this is a formula of simple harmonic motion. Okay, so if you're not satisfied with the fact that time t is simply observed in the trigonometric function right here, I can also give you another interesting point here. So f right here is frequency. Frequency is nothing but inverse of time. So frequency has a dimension t. Okay, let's just put that. Yeah, so t inverse. So apply that and you get t inverse times t. So these two add up together 1, so they go to 0, and therefore you just get 2 pi, and that's also a number. So therefore no matter how you look at it, your sine function becomes dimensionless, right? So A is, so therefore so if this is dimensionless, then A is equal to x. So therefore if x is L, A is also of length of dimension length. Okay, so thank you for watching. As always, if you have any doubts or suggestions or any queries that you want to clear up with me, you can write it down on the comment box below, or you can email me. I will put my email link in the description box below. All right, so have a good day and keep on practicing your problems. We'll do some other problems on dimension analysis, and then we'll move on to the next chapter. Thank you for watching.